Hello and welcome to the series of RapidMiner videos. My name is Dr. Marcus Hoffman and I'm a lecturer at the Institute of Technology Blanchardstown and also the principal investigator of this project funded by the Irish National Digital Learning Repository. The series of RapidMiner videos was created in close collaboration with Ralph Klinkenberg and Dr. Ingo Merswa, the two founding members of RapidMiner. More videos as well as additional material to some videos can be found at www.rapidminerresources.com. I would now like to introduce Ralph Klinkenberg, who will talk you through this tutorial.
Welcome to RapidMiner. This short video introduces support vector machines and how they can be used for learning classifiers. So let's first select a dataset. In the sample directory, there is a dataset on sonar data. It's a two-class problem, and the task is to classify whether a sonar measurement results from a mine or from a rock. We have 60 numeric attributes and one nominal label with two classes. So let's just now look for a modeling technique for regression or classification. In that case, it's classification. It's a two-class problem. And let's look for support vector machines. Before explaining the parameters, let's just see if the process works like this. Works fine. We generated a support vector model. And now the simplest support vector machine model is a linear model. That is, the function is a linear combination of all the input variables. And the resulting function is always attribute times the weight of that attribute and the decision whether it's above or below a certain threshold. If it's above, it's classified as the first class. If it's below, it's classified as a second class. So in that case, we generated a linear model to distinguish between rocks and mines. How do we know whether the model performs well? Well, we can add a cross-validation to measure whether it does do well or not. So we add a new building block, nominal cross-validation. Remove the SVM from that layer. Go into the cross-validation. Remove the decision tree. Put in a support vector machine. And just see how well it performs. You see an accuracy of 78.86%. If you remember the previous video with decision trees, this is even better than the better of the two decision trees. So even better than decision trees with discretization. So well, we didn't change any parameters. What are the major parameters of the support vector machine? Well, the central parameter is the kernel function. Do you want to train a linear classifier or a nonlinear classifier? If you would like to train a nonlinear classifier, the first option is a radial basis function. That's basically a combination of Gaussian exponential functions, and their combination results in a nonlinear, very fine-tunable function. Alternatively, you can have a polynomial function or a neural network-like function using sigmoidal activation units or other variations of nonlinear functions. The standard is linear and other options are nonlinear. Another important parameter is C. C describes whether the SVM should focus on being a robust and very strongly generalizing model, or if it should be a fine-tuned, highly specialized model, risking to overfit. C0 means a heuristic is used to automatically set the value. If you use another value like 0.1 or 0.01 or 1 or 10 or 100 or 1000, you basically specify how much influence an individual example may have in forcing the function separating the classes to be in a certain shape. That means the higher the C value, the more impact an individual training example can have. That means the more you force the SVM model to be highly specialized. And the lower the C value, the more generic and robust the model becomes. So there's a trade-off between having a small training error and highly specialized models on the one hand, and having a lower structural risk by having a more generic model. And this is what you can adjust by C. So the kernel function and the C value are the two most important parameters in a support vector machine. If your two classes have different importance or cost assigned to them when misclassified, you can actually also specify the classification cost for the positive and the negative cases. So for example, if you want to classify spam emails into spam and non-spam, misclassifying an important email to be a spam is quite costly, but having to read one spam message just takes a second and is not so costly. So in that case, you have asymmetric cost, and you may want to set this here in the parameters. So these are the most important parameters, and for now let's try to use a radial basis function and see what the impact is on the performance on this particular problem. The training for nonlinear functions may take a bit longer, and in that case the parameter setting doesn't seem to fit very well. So either it's rather linear than a nonlinear problem, or we have to adjust the other parameters in the SVM setting. Sometimes it's difficult to know which combination of parameters to use best. In that case, an automated parameter optimization can help. There's a separate video on that topic, and there you can specify which parameters to vary in which intervals, and then have the system automatically find the best combination. Also, a hint is to switch between beginners and expert mode, so you can see more or less parameters and focus on the most important ones if you're not so familiar with the method. Okay, thank you very much for your attention.
For further information on RapidMiner, please go to www.rapidminerresources.com or www.rapid-i.com. If you are interested in upskilling, please go to www.itb.ie, where you will find more information about our distance learning MSc in computing science, in business intelligence and data mining. Many thanks to the Irish National Digital Learning Repository for funding this video.